Hello everyone. So let's just solve the final assignment. Okay. So in this is the first question. You need to find the voltage V. Okay. And this is a 2 ampere current source. This is 5-volt battery. So what will be the voltage drop across this 2 kilo ohm resistance? What will be the voltage drop? Because this 2 ampere current will be flowing here. The voltage drop will be 4 volt. So what should be the answer of V? 9 volt? No. Why so? Because you don't know the voltage drop across this current source. The answer would be none of these, because you don't know the voltage drop across the current source. You know, if this is 0, this will be 5, this will be 9. But do you know the voltage drop across this current source? No, you don't. So your final answer would be none of these. Your answer would have been 9 volt plus the voltage drop across 2 ampere current source. Right? This should be your final answer. Okay. Let's move on to the next question. You have to find the value of I4. I4. This is I4. This is I4. Tell me what will be the value of this current. This current is getting divided into two parts, 7 ampere and 5 ampere. So 7 plus 5, that is equals to 12 ampere. So your I4 is basically equals to minus 12 ampere. This is the answer. 5 ampere current coming going that way, 7 coming that way. So 12 ampere would be coming from this side, right? So I4 is basically the negative of this current source. So I4 is minus 12 ampere. Well and good. Let's move on to this question. You have to find the value of voltage V. This voltage you need to find. Let's start from here. If this is ground, what will be the potential of this point? That will be V. We can come from here as well. If this is ground, this will be 4 volt. This will be 8 volt. This will be 8 minus 5. So your V would be 8 minus 5. That means minus 3 volt. Look, you started from here. If you go from here to here, it will be V volts. Now, if you go from here, if you walk like this, 0, 4, 8, 8 minus 5, minus 3. So your this potential is equals to minus 3 volt. That's it. You have to find the value of Vt. So how you can find? What is the current coming that way? E to the power At. What is the coming current that way? E to the power Bt. What is the total current here? E to the power At plus E to the power Bt. So what is the value of Vt now? Vt is L dit by dt. What is the value of L? L is 1. What is the integration of the current? That is A into e to the power At plus B into e to the power Bt. So your final answer is A into e to the power At plus B into e to the power Bt volt. That is your final answer. L di by dt, e to the power At, e to the power Bt, addition of both and simply the differentiation. Okay, A into e to the power At plus B into e to the power Bt. Okay, you have to find the value of E. If this is 0, if you start from here, what will be the potential of this point? V2 minus 2, right? V2 minus 2. So we shouldn't start from here. We should start from here. You know the potential of this point is 0. You know the potential of this point 0 minus 1. It will be minus 1 volt. Do you know the potential of this point? No, it is V1. You don't know. We should start from here. If this is 10, this will be 10 minus 5. 10 plus 5 actually. 10 plus 5. It will be 15. We started from here. 0 minus 1 minus 1 minus 1 volt. 0. Sorry, 10 plus 5, 15 volt. So what is the value of E now? Value of E is minus 1 minus 15. Value of E is, this is the positive terminal. At positive terminal we are having minus 1. What we are having at the negative terminal? At negative terminal we are having minus 15. So minus 16 volt. So the value of E is minus 16 volt. That's it. If they had asked you what is the value of V2, what is the value of V2 and what is the value of V1? So V2 minus 2 is equals to minus 1 volt. So V2 is 1 volt, right? And V2 is 1 volt. And what about V1? V1 plus 4 is equals to 15. So your V1 would be 11 volts, right? 11 plus 4, 15, right? Let's move on to this question. A fully charged mobile phone with a battery of 12 volt is good for 10 minutes talk time. Assume that during the talk time, the battery delivers a constant current of 2 ampere. Okay. For all the time, it is giving a constant current of 2 ampere. Current waveform I can make, that is constant 2 ampere, right? Now, its voltage drop linearly like this. We can see here, this is 2 ampere, this is IT. Now, you need to tell how much energy the battery delivered during this time. So what is the energy? Power into dt. So Vt into It into dt. So what is the energy? Energy is integration of Vt into It into dt. It is constant, that is 2, and during this talk time is 0 to 10 minutes. So 0 to 10 minutes 600 seconds, because joule is watt into second, right? So you have to convert minute into seconds. Okay, so what we did, 10 minutes is equals to 600 seconds, that we did here. Okay, so It is 2, then 0 to 600 Vt into dt. So basically we just need to find the area of this. So we can find it like this, 1 by 2 into addition of parallel side is 12 plus 10 into the height. This is the parallel side, this is the height is 600. Or you can think that this is a triangle, and this is not a square, this is a, what do we call it, अरे आयत को इंग्लिश में क्या कहते हैं, rectangle. Okay, this is a rectangle and this is a triangle. Okay, so triangle plus rectangle also you can do, or you can do like this, what we call the trapezium. Okay, so what is the area of the trapezium? 1 by 2 into the addition of the parallel side into the height. So addition of parallel side as these two, 12 plus 10 into the height. So it will be 22 into 6. So it will become 13.2 kilojoule. Okay, so this will be your final answer, 13.2 kilojoule. Okay, let's move on to the next question. In the interconnection of ideal sources shown in the figure, it is known that the 60 volt battery is absorbing power. What can be the value of current source I? So let's just see. Here we have 12 ampere current. Battery is absorbing power, that means the current would be getting into the positive terminal, right? So let's just assume I dash current is getting into the positive terminal because it is absorbing power. So what will be the value of I? Your I would be 12 minus I dash. So basically your I would be lesser than 12, right? So only one option is there for lesser than 12, that is 10 ampere. So 2 ampere current would be going into the positive terminal of 60 volt battery. That means this 60 volt battery is absorbing 120 watt power. Okay, you can't really tell the exact value, but you can say that the current would be less than 12 ampere. So there is only one option that is less than 12 ampere, that is 10 ampere. Okay, let's move on to this question. In the circuit shown in the figure, you need to find the current through the inductor. Okay, so like student may start like this. Let's just assume the potential of this point is 0, then they will write the potential of this point and they will write the potential of this point. So but what I will do is that I will assume the potential of this point to be 0. If this is 0, this will be 1 volt. What is this, what does this angle mean? So when you study AC analysis, that Anish sir will be teaching you. So when you study AC analysis, you will get to know what does this angle mean, or how do we write the angle. Everything you will get to know in one lecture only. Okay, so angle 0 means like 1 volt, we can write 1 volt with 0 degree angle. So this is 1 volt only, this is 1 volt only. Okay, so you don't need to think. Whenever there is 0 degree angle, that means it is DC only. So this is 1 volt, this is 1 ampere, this is 1 volt, this is 1 ampere. Okay, so if this is 0, this will be 1 and this will also be 0. because 0 plus 1 minus 1. So 0, 0 here. Let's just assume the potential of this point is V. Okay. Let's assume the potential of this point is V. Now we will write the nodal analysis. So V by J plus V by 1 is equals to 1 ampere, right? V by J plus V by 1 equals to 1 ampere because 1 ampere is coming into it. Okay. So V plus JV equals to J. So V would be equals to 1 plus J. V would be equals to J upon 1 plus J. Okay. Now what will be the current through the inductor? Let's just assume the current through the inductor is I1. So what will be the value of I1? I1 would be V by J. So that would be 1 upon 1 plus J. So if I write the magnitude, it would be, if I write it completely, it would be 1 by root 2 with an angle of minus 45 degree. Now how did I write that? You will understand it in AC analysis. Okay. I just picked this question if you already know the concept. So how did I write the magnitude? 1 upon 1 plus J. So it will be 1 upon under root A square plus B square. So it is 1 by root 2 and the angle is minus 45 degree. How did we write it? You will understand it in AC analysis. Completely you will understand that in AC analysis. Okay. So it is 1 by root 2 angle of minus 45 degree. Okay. Very easy question. Now this is the question. This is one network. You are given the value of VA minus VB, that is 6 volt. You are given the value of VA minus VB, that is 6 volt. Okay. One network is there, 6 volt it is given. You have to find the value of VC minus VD. Okay. So there is one concept. Whatever the current network releases, it takes back the same current. It takes back the same amount of current. Okay, this is very important point. You need to remember it. Very important point. Okay. So if this 2 ohm resistance is having 6 volt voltage drop, VA minus VB is 6 volt. So what is the current here? 3 ampere. Let's just make this box as a network. Okay, this box as a network. So what I am doing is that there is a network. Okay, and then there is this potential VA, there is this potential VC. Okay, there is this 2 ohm resistance with the current of 3 ampere. Okay, we have a current source here, we have a resistance here. This is 2 ampere, this is 1 ohm. Now you see one thing. Here we have one more network, that is this. We have this one more network, right? That is this network. Okay, this potential is VB and this potential is VD. Okay, now you see this 3 ampere current is getting into it, right? This 3 ampere current is getting into this network. That means this 3 ampere current would be coming here, out of this as well. If this 3 ampere current is getting out of here, that means this 3 ampere current would be getting into it as well. Network 3 ampere current is getting out, that means 3 ampere current would be going in as well. 3 ampere current is going in, that means 3 ampere current would be getting out as well. So whatever it takes, it gives back the same. Same with the battery. If it gives 10 ampere current, let's just assume this is a battery of 10 volt and there is some network. Okay. If it is giving 10 ampere current, it will take back the same amount of current. Okay, same with the battery. Whatever the current it gives, it takes back the same current. Okay. We will see the question based on this as well. So now you know, if this is 2 ampere and this is 3 ampere, that means 5 ampere current would be coming from here, right? Or you can see Here we have 2 ampere current, here we have 3 ampere current. So total 5 ampere current would be going that side, right? So what will be the value of Vc minus Vd? Vc minus Vd. Because of 5 ampere current, we will have a drop of like this. So Vc minus Vb would be minus 5 into 1, that would be minus 5 volt, right? So this is our answer. So only one concept that was used, whatever the current it takes, it gives the same amount of current, okay? Or whatever the current it releases, it takes back the same amount of current. So here it is taking 3 ampere current, it will give 3 ampere current. So 2 plus 3, 5, the Vc minus Vd would be minus 5 volt. Okay, easy question, well and good. Let's move on to the next question. This is a very good question. Okay, now the thing is breakdown voltage. What is the breakdown voltage of a capacitor? Breakdown voltage of capacitor. Voltage of capacitor is the maximum voltage it can take. That's it. If you give it more voltage, it will just break down. The maximum voltage a capacitor can take. If you give more voltage than this, it will burn out. Okay, the capacitor will burn out. So this is the maximum voltage it can take. Maximum voltage means it is the maximum charge it can take basically. Okay, so we have capacitors. Do I have the next page? No, I will add a page here. So we have capacitors like this. Okay, so value of C1 is 10 microfarad, value of C2 is 5 microfarad, and value of C3 is 2 microfarad. Breakdown voltages are 10 volt. So this is C1, this is C2, and this is C3. So breakdown voltage of C1 is 10 volt. So Q maximum, Q equals to CV, right? So C1V. So maximum charge it can take is 10 micro into 10 volt. That means 100 coulomb. So C1 can take maximum 100 microcoulomb charge. Similarly for C2 and C3. So for C2, breakdown voltage is, what is the breakdown voltage for C2? That is 5 volt. That is 5 volt. So your Q max for C2 would be 5 into 5 micro. That means 25 micro coulomb. And for C3, your Q max will be 2 into 2 micro. That means 4 micro coulomb. Let's just make the circuit again. Five and 2, 5 microcoulomb, sorry, 2 microfarad and 10 microfarad. Okay, so now this capacitance C2 can take 25 microcoulomb, this capacitance can take 4 microcoulomb, and this capacitance can take 100 microcoulomb. Okay, but we have studied one thing. What is that? In series, the current has to be same, right? That means the charge on capacitor has to be the same, right? Because I is equals to dq by dt. If the current is same, the charge has to be the same, right? The change in charge. Actually, the change in charge has to be the same, but initially all of the capacitors are having 0 coulomb charge. Then the total charge finally would be the same. So the charge on the capacitor has to be the same. Now, what do you think? How much charge you will be applying on this? How much charge you will be giving to this capacitor? this capacitor and this capacitor. What do you think? Can you give 25 microcoulomb to this? Then if we give 25 microcoulomb to this, then we also have to give 25 microcoulomb to this, right? Because the charge has to be same. If I am giving 25 microcoulomb to 5 microfarad, that means I have to give 25 microcoulomb to 2 microfarad as well, because the charge has to be the same. But if I give 25 microcoulomb to this 2 microfarad, what will happen? This will burn out, because this 2 microfarad can only have 4 microcoulomb, right? So what I will do? I will give 4 microcoulomb to, I will give 4 microcoulomb, 4 microcoulomb to this capacitor. Then I have to give 4 microcoulomb to this capacitor as well. If I give 4 microcoulomb to this capacitor, it can take 4 microcoulomb, because maximum it can take 25 microcoulomb. Are you getting this point? If I had given 25 microcoulomb to both, for 5 microfarad it would be good, but for 2 microfarad 25 microcoulomb cannot be handled, right? So the C3 capacitor can only take 4 microcoulomb. So I am giving 4 microcoulomb to it, so that this 5 microfarad capacitor, that means the C2 capacitor can also have 4 microcoulomb. Are you getting this point? Right? So this will have 4 microcoulomb, this will also have 4 microcoulomb. So 25 microcoulomb charge cannot be handled by 2 microfarad capacitor. We will give minimum charge. So the charge given to 5 microfarad is 4 microcoulomb, and charge given to 2 microfarad is also 4 microcoulomb. Okay. Now I will put the charge on my laptop. Yeah. So C2 and C3 are given 4 microcoulomb charge, so that C2 and both of the capacitor don't go into breakdown, right? Okay. So both of the capacitors are given 4 microcoulomb charge, so that both of the capacitor don't go into breakdown. Okay. So tell me, what will be the voltage across C2 now? Because Q equals to CV. So it would be Q across C2 by C2 capacitance. So Q equals to CV. So voltage would be Q by C, right? So tell me, what is the charge across the capacitor? That is 4 microcoulomb. Now why we are doing so? Now what we will do, we will get the voltage across both of the capacitor, then the same voltage will be across this capacitor only, right? Addition of these two voltages will be the equivalent voltage across this capacitor, and from there we will get the charge. This is what we are doing. Are you getting this point? I will get the voltage across 5 microfarad, I will get the voltage across 2 microfarad. The total voltage will be the same voltage across the 10 microfarad. So if I have the voltage across the 10 microfarad, I will get the charge from there. You know the charge across 5 microfarad and 2 microfarad. Now you are finding the charge across 10 microfarad. So what is the voltage across C2? That is QC2. What is the value of QC2? That is 4 microfarad. Sorry, 4 microcoulomb. 4 microcoulomb divided by what is the value? That is 4 microfarad. That means 0.8 volt. What is the value voltage across C3? That is, what is the charge? 4 microcoulomb. Yeah, 4 microcoulomb divided by 2 microfarad. That is 2 volts. So basically, one capacitor, 2 capacitor, and this capacitor. This is 10 microfarad. This is having 0.8 volt, and this is having 2 volt. So total 2.8 voltage will be across capacitor C1, right? So in parallel, the voltages are same. That means value of voltage across C1 is 2.8 volt. So what will be the charge across C1? Tell me, what is the charge across C1? 10 micro into 2.8. That means 28 microfarad. Right? So what are they asking? The corresponding total charge stored. Okay. The total charge stored. So total charge stored is 28 here and 4 here. Right? So 28 plus 8. That means 36. So the total charge will be 28 microfarad. Sorry, coulomb, not farad. 28 microcoulomb plus 4 microcoulomb plus 4 microcoulomb. And one more thing I need to notice is that this C1 can take 28 microfarad or microcoulomb charge or not. That 10 microfarad capacitance can take 28 microcoulomb charge or not. Yeah, it can take. The maximum charge it can take is 100 microcoulomb. The maximum charge it can take is 100 microcoulomb. So it can take 28 microfarad. So this is the total charge, that is 36 microcoulomb. And what did they ask? 36 microcoulomb. And what is the voltage? The voltage is 2.8. So the answer would be this 2.8 and 36. How did we get it? This 2.8 voltage already we see here, right? 2 volt here, 0.8 volt here. So 2.8 voltage is across the terminal. Across this terminal, they are asking the voltage. Look, what did they ask? The total charge stored in the effective capacitance across the terminal and the safe voltage that can be applied across the combination. So what is the voltage that can be applied across the combination? That is 2.8 volt, right? Here we are getting 2.8 volt. Here we can see 0.8 volt to this, 2 volt to this, so total 2.8 volt. And total charge is 28 plus 4 plus 4. 4 microcoulomb plus 4 microcoulomb plus 28. The total charge would be 36 microcoulomb. So answer A is the final answer. It was a very good question. I hope you have understood the concept. Okay, let's move on to the next question. You have to find the equivalent capacitance in the input loop. Okay, equivalent capacitance in the input loop. That means what you will do? You will be applying a voltage here and measuring the current, right? So basically your Z equivalent would be V by I1. Okay, so let's just see what is V. V is equals to, tell me one more thing. If there is I1 current coming that way and 49 I1 current coming that way, that means how much current is coming here? 50 I1, right? I1 current coming here, 49 I1 current, total 50 I1. So V is equals to 2 kilo ohm into I1 plus 1 by J omega C 100 microfarad into 50 I1, right? 1 by J omega C, this is the impedance that a capacitance provide, right? C capacitance will provide 1 by J omega C. So 1 by J omega C value is 100 micro, right? Into the current. Current is 50 I1. Here the current was I1. Here in the capacitance the current is 50 I1, right? So V is equals to 2K plus 1 by J omega 50. This 50 will be cancelled with 100. So it will be 2 microfarad into I1. Here also I have I1. So from here you can see V by I1 is equals to 2 kilo ohm plus 1 by J omega 2 microfarad, right? So this is your R equivalent and this value is your C equivalent, right? So what is the equivalent capacitance? That is 2 microfarad. So answer is 2 microfarad. So here I can write C equivalent is 2 microfarad. I1 current 49 I1, 50 I1 current. So basically This 50 I1, it get cancelled by 2. So the capacitance has been reduced to 50 times. Like if there was I1 current through it, it was 100 microampere. If there is 50 I1 current through it, it will be reduced by factor of 50. Or you can simply derive it, 550 will be cancelled with 2. So the C equivalent is 2 microfarad. Very easy question. Simply you write down the equation and you will get to the final answer. Okay, it won't take much time if you solve it in exam. Okay. So if they had asked you what is the equivalent resistance, your equivalent resistance would be 2 kilo ohm. So your R equivalent is 2 kilo ohm and your C equivalent is 2 microfarad. Okay. Let's move on to the next question. So there is one term introduced that is known as load line. So what is load line? Basically, load line is relation between two quantities. So here the relation they are defining between V and I. So they are defining as V plus I is equals to 100. So if I take V at I axis, sorry, V at y axis, so I can write it like this: V equals to 100 minus I. Okay. So now I can draw the waveform between V and I. V and I. So when I is equals to 0, that means V is equals to 100 volt, and when I is equals to 100 ampere, that means V is equals to 0. So this is the curve, right? Or I can use a different color pen. So this is the curve. So this is one relation. There is one more relation between V and I. What is that relation? This is V, right? And this current I is I. So V is equals to, basically this is first relation, and the second is V is equals to I into R. Basically V is equals to I. This is the second relation. So what is the graph of V is equals to I? The graph of V is equals to I is like this. So at what point these two graph cut? They are cutting at this point. This is known as operating point. Okay, operating point. So at this point your circuit will run. So your circuit is running at this point. So you need to find the value of V and I here, or they are simply asking the current. So you just need to find the value of current I. So just solve these two equations. That's it. So put I equals to 100 minus I. So your I value is 50 ampere. That's it. That's the final answer. Very easy question. I just picked the question so that you get to know the meaning of load line. Okay. So load line is basically the relation between two quantities, V and I. So we just draw the graph, then we drew one more graph. So this is the operating point that we are getting. So this operating point is 50 volt and 50 ampere. Because V is equals to I, if we are getting I equals to 50 ampere, that means voltage is also 50 volt. So the current value is 50 ampere. Okay. Simply two equation and two variable and two equations. So you can just simply get the value of V and I. Okay. Now this question, try to solve it on your own. I have given one concept related to that. What was that concept? Whatever the current a network releases, it takes back the same amount of current. Tell me what is the value of current here? 10 by 5, 2 ampere. What is the value of current here? This is also 2 ampere. If this network is giving, oh sorry, not 2 ampere, 1 by 5, no, it is 1 by 5. So it is 0.2 ampere. V by R, okay, it is 5 ampere. It is 5 ampere. It is 5 ampere. V by R, 5 ampere. So 2 ampere current and 5 ampere current. So this network is giving 7 ampere current. That means it will take back the 7 ampere current. Right? Now they haven't given the polarity of the voltage. So we have to assume the polarity is like this only. Because in these two resistors they have made the polarity like this. So I will assume the polarity is like this. So what is the voltage drop across 15 ohm resistance? You tell me. Is it plus 105 or minus 105? It is minus 105, right? So let's just call it voltage V. Let's just call this voltage V naught. Okay. So your V naught is, current is flowing in this manner because 2 ampere current is going out, 5 ampere current is going out. So 7 ampere current is going out, so 7 ampere current would be getting in. So V naught would be minus 15 into 7. That means minus 105 volt. Okay, so your V naught value is minus 105 volt. So this is the final answer. Okay. 3 circuit elements shown in the figure as are a part of an electrical circuit. Like this is a part of electrical circuit. This circuit is not completely given. You need to find that total power absorbed by these 3 elements. Okay. So tell me one thing. 10 ampere current is going this way. 8 ampere current is going this way. So how much current will be going this way? 2 ampere current. Let's talk about 15 volt battery. 2 ampere current is getting out of the positive terminal. So it is delivering power, right? What about this? 8 ampere current is getting out of the positive terminal. It is also delivering power. What about this? 10 ampere current is getting into the positive terminal. That means it is absorbing power, right? So what is the total power absorbed? Power absorbed. Power absorbed. This is absorbing power. Now this is delivering power. So I will write it as minus. This is also delivering power. So I will write it as minus. So 1000 minus 30. So it will be 330 watt, right? Power absorbed. So they are asking about power absorbed. If they had asked you what is the power delivered, then you would write minus 330 watt. Now you will say that in the theory part I told you that power delivered is equals to power absorbed. Yeah, that's right. But that's for the complete circuit. This is just a part of a circuit. Okay, there can be other elements too. So in this part of circuit, 100 volt battery is absorbing power of 1000 watt. Okay. 80 volt battery is delivering power of 640 watt, and this 15 volt battery is delivering power of 30 volt. Okay. So total power delivered is 670 watt, and total power absorbed is 100 watt. So what is the total power absorbed? That is 100 minus 670. That means 330 watt. Okay. Now let's see the question. A 100 ohm and 1 watt resistor and a 200 ohm and 2 watt resistor are connected in series. The maximum DC voltage that can be applied continuously to the series circuit without exceeding the power limit of any resistor. Okay. 100 ohm resistance, and then we have 800 ohm resistance. Okay. The power is 2 watt and here the power is 1 watt. Okay. So tell me what will be the current, like what can be the current across 100 ohm? That can be power is I square R. So the current is under root P by R, right? So it would be 0.1 ampere. What should be the current through 800 ohm resistance? It would be P by R. So it would be 2 by 800. So it would be 1 by 400. That means it would be 1 by 20, right? 1 by 20. So it would be 0.05 ampere. So this is saying I will have 0.1 ampere current. This is saying I will have 0.05 ampere current. So the maximum current it can take is, this is the maximum current, right? So maximum current it can take is 0.1 ampere, and maximum current it can take is 0.05 ampere. So how much current will flow finally? So finally 0.05 ampere current will flow, right? So 0.05 ampere across 9 kilo ohm resistance. Sorry, 900 ohm resistance, right? So your voltage drop will be 900 into 0.05. That means 45 volt. So this is the safe voltage, because we have to give them minimum, right? Because if I give 0.1 ampere current, this resistance will say I can't take 0.1 ampere current. I can only take 0.05 ampere current. So if I give 0.05 ampere current, this 100 ohm resistance will say, yeah, I can take 0.05 ampere current. So the minimum current we will flow. So 900 ohm resistance is there, 100 ohm plus 800 ohm, both of the resistance are having 0.05 ampere current. So 900 into 0.05, so 45 volt is the final voltage drop across this resistance. Okay, so we are not exceeding any power limit. If 0.05 ampere current is flowing through this resistance, what is the power across this? That is 0.5 watt, right? 5 by 100. Wait a second. Wait a minute. There is some error, I guess. Yeah, no error is there. It's fine. Like if 0.05 ampere is current is flowing through this 100 ohm resistance, what is the power it will have? 0.05 whole square, 0.05 square into 100. So that means it will have 0.25 watt power, right? 0.25 watt, and it will have 2 watt power, right? 0.005 square into 800. So it will have 2 watt power. This will have 0.25 watt power. Okay, so no power limit is exceeded. So this is the safest voltage we can apply. Okay, let's solve this question. And in all of the books I have seen the solution wrong for this. Okay, they actually get the final answer, but the solution, the method that they use is, I guess, wrong. Okay, as per me it is wrong. Like, what is the concept of bridge circuit? What does a bridge circuit really mean? Let me just make a bridge circuit. Okay, this is the bridge circuit. Now, if I say the bridge is balanced, the bridge is balanced, the bridge is balanced across CD. Okay, the bridge is balanced across CD. So what does that mean? The current in this resistor, the IR is 0 ampere, right? That means your VA is equals to VB. So if your bridge is balanced, then the nodes that are opposite to the applied voltage, the nodes which are opposite to the applied voltage, the applied voltage is here, these nodes are opposite to the applied voltage, they can be short circuited, right? If the bridge is balanced, that means that the nodes that are opposite to the supplied voltage, they can be short circuited. So I will just write it down. Okay, I will pause it and write it down. So in a balanced bridge, the nodes which are opposite to the nodes of applied voltage. So we are applying the voltage across these two nodes. So these nodes are opposite to the applied voltage. So they can be short circuited, right? So in the given question, the bridge is balanced. So I have to write it like this: R1 into R2 equals to R3 into R4. This is given actually. This is given. Okay, this is given that bridge is balanced. So yeah, in the question, what is happening is that now these two nodes can be short circuited, right? Because they are opposite to the applied voltage. So these two nodes can be short circuited. So now this node and this node, we have a voltage here and we have a current coming here. So let's just assume this is the current coming here. Okay, this is the current coming here. This is 2 volt, and here we have 1 kilo ohm, 4 kilo ohm and 2 kilo ohm. 1 kilo ohm, 4 kilo ohm and 2 kilo ohm. These can be short circuited, and the current through this will be 0 ampere, right? Because we have seen here the current through this is 0 ampere. So now this 2 volt, if both of them are short circuited, then this 2 volt will be coming here, right? Right? That means it will have, now if 2 volt is coming here, that means it will have a current of 2 ampere, 2 milliampere, you can say. 2 milliampere, because 2 by 1, that means 2 milliampere, 2 milliampere. The current here is 0, that means the same current will be flowing here, 2 milliampere. That means it will give a voltage drop of 8 volt, right? Now this same voltage drop will be going towards this, and because of this 8 volt voltage drop, we will be having 4 milliampere current here. Did you get what did I do? Both of the nodes are short circuited, so this 2 volt is going here. So 2 volt by 1 kilo ohm, 2 milliampere current is coming here. Now in this branch there is no current, so this same current will be flowing here. So this 2 milliampere current is the same 2 milliampere current is flowing here. So that means this 4 kilo ohm resistance is having 8 volt voltage drop. Now this same 8 volt voltage drop will be going towards this 2 kilo ohm resistance. So this same 8 volt voltage drop is towards this 2 kilo ohm resistance. So 8 by 2 kilo ohm, that means 4 milliampere current is coming this side. So from here we are having 4 milliampere current, and here we are having 2 milliampere current. So the current I is 2 milliampere plus 4 milliampere, that means 6 milliampere. So this is the final answer actually. Okay, so this is how you need to solve it. What I see in most of the books is that they say that this is a balanced series. So what they will do is that multiplication of these two should be equal to multiplication of these two, right? So what is the multiplication of these two? That is 2, right? 2 into 1, that is 2. Now to make the multiplication of these two, they will connect a 0.5 kilo ohm resistance here. Now multiplication of this will be 2 into 1, 2, 4 into 0.5, 2. Now this 0.5 kilo ohm resistance is having 2 volt voltage drop. So what is the current it is having? 2 by, I am not saying this is the correct method, okay? I am not saying this is the correct method. So they are saying we are having 4 milliampere current here. Okay. Now they say here I have 2 plus 0.5 kilo ohm resistance. So 2.5 kilo ohm resistance I am having, and here I am having 5 kilo ohm resistance. So if we are having 4 kilo ohm resistance here, this resistance is doubled. So we will have 2 milliampere current here. So 2 plus 4, 6 milliampere. This doesn't really make any sense. Answer is correct, 6 milliampere. Okay, fine. But this doesn't really make any sense. What you are doing here? How can you assume a resistance there? Then the same voltage drop across that, then you are finding the current, then you are saying 2 plus 0.5, so I will have 2 milliampere. This doesn't really make sense. What is the actual concept? The actual concept is that if the bridge is balanced, that means these two nodes will be equal, and in this node there will be no current. So this is the first point to note, and this is the second point to note. These two are the most important point if we are talking about a balanced bridge. Potential same, no current, that's it. Potential same, then 2 volt will be coming across this 1 kilo ohm resistance, this 2 volt will be coming across this 1 kilo ohm resistance, that means it will have 2 milliampere current, and the same current will be flowing through this 4 kilo ohm resistance. It will give a drop of 8 volt, so the 8 volt will be going across this 2 kilo ohm resistance. So 8 volt by 2 kilo ohm, that means 4 milliampere current is flowing like this. So 4 milliampere current is flowing here, 2 milliampere current is flowing here, so total current is 6 milliampere. So this is the final answer. Okay, so that's it. That's why I took this question actually. Okay, so now I hope you guys are comfortable in basic concepts of network analysis. We will see one more concept. Okay, it is also a very basic concept, but in GATE 2022 they asked a question from that, and many of the solutions were wrong. Okay, so I will also deal that concept in the next video itself. It will take around 5 to 10 minutes, or I can add it up in any other video. I can add that video in any other video because it will be only 10 minutes, so it will be a waste of time. So I will add that up in some other video. Okay, so one more concept is left. Okay, and I hope now you guys are very much comfortable with the basic concept of network analysis. So now what you can do is that you can go and attempt the previous year questions of GATE for all the branches, EC, electrical and instrumentation, only for basic concepts. This is a bit what do we say, like thoda bada chapter hai. Okay, like it is a lengthy chapter, but network theorem will not take much time. Transient analysis will take time, but network theorem will not take much time. And network analysis is asked for 8 to 10 marks in the examination. So I have to spend time here. Okay, and this is the basic. If you study network analysis well, you will be very much comfortable with analog electronics. Okay, and you will be comfortable with control systems as well. So you have to study network analysis very deeply. So now I hope you are comfortable with the basic concept of network analysis. So yeah, in the next video we will be starting with the concept of network theorem. Okay, then if you are liking the video, If you think the content is good, then please try sharing it with your friends. Okay, thank you.